Okay, they're getting out the really intimidating trig identities now. Let's see if we can prove this. Sine x cosine squared x plus sine cubed x equals 1 over cosecant x. Cosecant x. Another general tip when you're doing these proofs, start on the more complicated side. There's more stuff to work with there. If you start with 1 over cosecant x, you're like, oh, what do I do with this? I can turn it into sine x, which is good, I suppose. But after that, it's hard to know what to turn this into. When there's a lot of different stuff, you have more possibilities for combining and canceling and reducing. So let's see what we can do over here. I notice right away we've got a common factor here of sine x. Let's pull that out and see if it helps at all. That leaves us with cosine squared x plus, do you see it? Something good just happened. Pythagorean identity, cosine squared x plus sine squared x, is just 1. So this left-hand side, just like that, turns into sine x. Nothing to it. I thought this one was going to be a real bear to simplify, but it wasn't bad at all. Now, non-permissible values for this. We have no roots and we have no division on the left-hand side. So the left side, there's no restrictions on our domain. On the right side, we have cosecant in our denominator, which means the non-permissible values would be cosecant x must never equal 0. I'm not sure what that means. Let's see if we can simplify it somehow. Cosecant is 1 over sine, so we get 1 over sine x is never allowed to be 0. And if we do the reciprocal of that on both sides, we get sine x is never allowed to be, 1 over 0, which is undefined. That doesn't mean a heck of a lot. Sine x is never undefined. It just keeps bouncing between -1 and 1 forever. So it's fair to say, yeah, we don't want sine x to be undefined, but since that never happens, I believe this expression doesn't have any non-permissible values.